Hi, everyone. Welcome once again to this channel and on our series on strength of materials. Kindly subscribe, like, share, leave comments and suggestions at the comment section as well. Today we are looking at how to solve problems in strength of materials. And we are looking at determination of normal stress on columns. Determination of normal stress on columns. That is what we are looking at today. So let's look at our question and how to solve the problem. Good. Example 1. The column shown below is subjected to an axial load of 130 kilonewtons at the topmost part. Calculate the normal stress at the section labeled as GG if the load is applied at the centroid of the column. And we have this diagram on the screen. So let's look at how to deal with this kind of problem. Good. So this is our problem today, and we want to look at how to solve this problem which is on our screen. We are told to find the normal stress on this plane. So we are talking about this plane here. When we cut this column transversely along this plane which we have here, what will be the stress distribution at that portion? And so we are told that the axial load is 130 kilonewtons, which is equal to 130 times 10 to the power 3 newtons. And we know that the normal stress, which is also referred to as the direct stress, is equal to the load applied over the area. And this area is the area perpendicular to the point of application of the force, the point of application of the force. Therefore, in this case, we are told that this plane, therefore, it means that we should calculate the area in the column there. We can say that because this looks like a rectangular figure, we can say that our area is equal to length times weight. However, looking at the shape there, looking at the shape of the column, we can divide our area into two main sections. You can see that all this side is follow, all that side is follow. So we can divide into this. You can take this as one area, and then we also take this side as another area. And you can see that this and that, they are the same. They have the same dimensions according to the figure. So they are going to be the same. If this is A1, this is A1, this will also be A1. And then we have another area at this side. So let's make this area as A2. So it means that our total area is going to be, we have two of the A1s. This one is A1, this is also A1. They have the same dimensions. Therefore, we can say that we have two A1 plus A2, which is this middle section, A2. Good. Having been able to do this, the next thing we ought to do is to calculate the areas. So we can say that our area A1, now looking at A1, is a rectangle with length 5 plus 5, and then the width is 2. So the length is 10, 5 plus 5, which is 10, times the width, which is 2. And that is going to give us 20 meter squared. And A2, the thickness from the diagram, we are told that the thickness is 2. And we want to calculate the area A2. From A2, we can see that it is from this point. It is from this point here. The length is from this point here to this point here. And we are told that from this point to that point is 8. From this point to that point is also 8. Therefore, it means that the length from this side to that side is going to be 16. So we have 16 times the width, the thickness of that side. We are told that it is 2 meters. Therefore, we have 16 times 2. So from here, we can say that our A2 will be equal to 32 meter squared. For the total area, if we cut through the GG section, we are going to get our area is equal to 2A1, and we have seen that A1 is 20 plus our A2, which is now 32. So from here, our area is equal to 40 plus 32, and we can say that A is equal to 72 meter squared. Good. Once you have been able to calculate the area, the rest is very simple. We just write our stress formula again. Stress is equal to the load over the area, and from there we can say that our stress is equal to 130 times 10 raised to the power 3 all over the area, which is now 72. And from there we can say that our normal stress at that section will be equal to 180.6 Newton per meter squared. And 1 Newton per meter squared is the same as pascals. Therefore, we can say that our unit will be 180.6 Pascal. And that was quite simple and very easy to understand. However, if you have any comments or anything you don't understand from this side, you can let us know, and we will be glad to assist you and help you to understand this kind of problems or this kind of questions. Thank you very much for staying in touch with us. Thank you for watching. Kindly subscribe, like, share, and hit the notification bell. Once again, we are glad to have you. We will end here for this session. We'll meet again in our next video. Until then, bye-bye.